sir.
Okay,
1 minute, sir.
okay.
Good afternoon, one and all. The only way to do great work is to love what you do. I am Supriya Naika hosting this program. Creative. Creative is a group of people who are eager to gain new knowledge. Creative, cre means creativity, active means activeness. Creative things makes us active. Creative mainly focus on non-textual, non-academic, non-syllabus related concept, and my vision of creative is to build constructive thinking on various domains. Every Saturday we organize online talks on our Zoom platform, and we live stream our program on Creative GBD YouTube channel. Creative is thankful to all our resource person for engaging us with their knowledge. ISRO has established partnership with prominent Indian university such as Indian Institute of Science and various other state and central universities. This collaboration involves joint research project, student exchange program, and sharing of faculties and experts. Today, we are going to know more inside stories and experience of this collaboration with Bangalore University. To present today's topic, we have Dr. Kamsali Nagraj sir with us today. Today's creative topic is ISRO Initiative, University Collaboration for Chandrayan and Mars Mission, my experience. And I welcome today's speaker and all the participants for today's talk. And I call Mr. Ganesh to introduce today's speaker. Over to Ganesh.
Good afternoon to everyone. Myself Ganesh Kumar. So today it's our 96th episode on Creative, and we have speaker Dr. Kamsali Nagaraj sir, Professor, Department of Physics, Bangalore University, Gnanabharati Campus, Bangalore, on a free virtual talk on ISRO Initiative, University Collaboration for Chandrayan and Mars Missions, my experience. And we can know more about sir. And sir, academic qualifications we have. And sir completed his PhD in physics in 2003, University of Mysore, and MSc in physics 1996, Kuvempu University, Shankarghatta, and BSc in PCM 1994, DRM Science College, Kuvempu University, Davangere. And sir have lot of fields and area of interest. Atmospheric science, environmental radiology, aerosols, atmospheric electricity, global electric circuit, monsoon studies, meteorology, and dynamics of atmosphere, solar variability and monsoons, cloud physics, meridian atmosphere, modeling studies. And sir had 10 years of teaching and 15 years of research. And sir had research projects, 5 projects from ISRO, and additional responsibilities sir has coordinator Sir M. Vishwesvaraya, ISRO chair, and secretary Indian Meteorological Society Bangalore chapter, COSPER associate International Space Agency, life member of 8 professional bodies involved in popularizing of atmospheric and space sciences. And number of PhD students are doing with guidance of sir. And sir publishes some journals and proceeding conferences. And sir had publishes in reputed national and international journals 82 and 134 representation in national, international seminar and conferences symposia. And ಈಗ ನಾನು MSc ನ ಫಸ್ಟ್ ಇಯರ್ ನ ಜ್ಞಾನಭಾರತಿ ಕ್ಯಾಂಪಸ್ ಅಲ್ಲಿ ಓದ್ತಿದ್ದೇನೆ. ಇನ್
Ganesh, audio disconnected, sir. Sir, okay. Ganesh.
Okay. Nice, Supriya.
ma'am.
We'll continue as a time part. Thank you, one and all. Thank you for the creative group, and particularly Supriya, Srinath from ISRO for inviting me, and for also calling me for the possible kind of an interactions with the group. I hope I am audible to all of you. First of all, I would like to mention my gratitude to Dr. Ganesh Raj K. Sir is there, former director of Respond and also the IRRSC. Dr. Shipati, my own colleague from media department. The two students from my department, that is Ganesh and Chaitra. And so I hope Jahanavi joined. And Supriya was also one of my students, or our department student in 2010, who succeeded. She succeeded in master's program. This is an initiative they're calling it as fine. Actually, I'm also like you as a student of this department, student of physics actually, from the Kwamp University, and had nuclear physics as one of my specialization. But for my PhD program, when I did it from Mysore University, now it's called as University of Mysore, I took this subject on atmospheric science. But the problem is with the physics and law only. Worked in Indian Institute of Tropical Metallurgy as a fancy, and the exposure I got it from Indian Institute of Tropical Metallurgy and University of Mysore during my course made me to start the activities to go up with the phenomena, to go ahead with the concepts from the atmospheric science. When I joined Bangalore University in 2007, it was nice place and a good comfortable number of faculty members were there, almost 24 were there. Right now we are 11. And we requested for the commencement of the atmospheric science. The department and the university has published. We started the atmospheric science under the umbrella of ISRO's support in physics department. Atmospheric and Space Science Research Lab is a well-established lab from last 12 years. And I will share my experience or maybe hard and fast rule in such a way that how that the ISRO or maybe any space agencies or any of the agencies supports the universities, particularly in academics and research. I'll put my best effort. We'll try to see how it has to go. To begin with, let us see that how that legacy and the history of the Bangalore University has started. The Department of Physics is one of the oldest department in Bangalore University. It was started in 1882 with the Madras province. They can call it was under Madras University in Central College campus. You can see on the left side corner. The Bangalore University has come in 1964. But later from 1882, the Central College shifted to the University of Mysore during 1916. What the Central College picture you can able to see that. During 1964, Bangalore University is carved out of the University of Mysore. The establishment of the Bangalore University has started in Central College campus, Edgewood Central College campus. Still, the people used to call that as the Central College only. Right now, it is the Bangalore City University. Bangalore University established new campuses at Jnana campus in 1973. Of course, there was a trifurcation. That is the Bangalore University, because of the large number, either in student strength and handling the number of the colleges, affiliated colleges, has trifurcated into Bangalore University, the existing where I am working right now in Jnana campus, Bangalore City University, and Bangalore North University. Some of the faculty and the students are well aware of it. Of course, Chintamani is one of that, where Dr. Dinesh and other his colleagues, along with the students, are also regular members of this recreative. After that, see that Central College was started in 1858 in a Bangalore high school, Edgewood building. Okay, thanks to the community at that time. Actually, Bangalore High School has converted into the Central College during 1875 in Central College campus. Then later in 1973, Bangalore University shifted to the Jnana campus under the leadership of Dr. H. Nasimaya, a freedom fighter, a well-known physicist, a founder of National College to a great extent, Jnana campus. You can see that at that time Central College campus was there. This Central College has been converted into the Bangalore City University right now. This is the new picture. Then this is the existing picture of the Bangalore Administrative Office with the logo Jnanam Nahi Vidyanam Nahemha. As a genesis and the journey is considered, Bangalore University right now offers all 6 faculties: Faculty of Science, Faculty of Arts, Faculty of Law, Faculty of Commerce and Commerce, Faculty of Education, Faculty of Engineering. Almost 6 faculties in Karnataka. This is one of the university which offers all the 6 faculties put together. Means students from Science, Arts, Commerce, Law, Education, Engineering will be there at Jnana campus, of course, of the Bangalore University. 31% of the students belongs to the Science and Engineering, individually about 23%. As far as the number of the courses or programs are considered, in 1882 to 1915, physics is the one of the oldest department I told. Hardly 4 departments were there to commence with. Then when Mysore University formed, or it became the part of the Mysore University from the Madras University, 11 courses were offered. Bangalore University came to the existence in 1964, the 2nd June of 1964. 92 programs were offered between 64 to the 2016. See the growth, how it has happened. Right now, between 17 to 20, from last 5 years, we are offering about 108 programs. Means like physics is one program for master degree, chemistry is in one more program, sociology is in one more program, law is in one more program, MTech engineering is in a program, like that. If you see the streamline, just I want to spend some time actually, because this is one of the greatest university where we are there right now. You are also be part of it actually one or the other day. In 1882, physics started. About 1898, applied geology has started. Chemistry in 1908, 1909 zoology. All of them already celebrated 100 years, centenary year actually. That was under Madras province or with Madras University. Between almost about 16 to about 63, 64, almost 5 departments were joined under Madras, almost 11 courses. There are right now 108 courses which are spanning or which are covering all disciplines from science to the arts and commerce, law, education, and engineering. And this is the one thing from 64 to 2017, how the university has evolved in starting the new courses in one or the other year, one or the other programs. The bottom panel shows that these are about 16 new programs which are offered in Bangalore University from 17 to 22. That is the last 5 years, particularly MA in Media Studies. Dr. Shripati is there right now. He was the coordinator for that one. MA Public Relations, Filmmaking, Forensic Science, and along with that, some courses has honors under National Education Policy like BA Honors, BSc Honors, BCom Honors, BSc Geography, and also in Engineering. This is our university with the tallest track harvesting pole of about 150 feet, which is the highest in Karnataka. Welcome to the Department of Physics. This is the one of the department where I taught. Left extreme is on the top panel. We can see that is the front panel of the photograph of that. The bottom one, when during the celebration of last year, August 15th, Independence Day, all faculty and staff were there, including some of you might be there right now. This is the new version where some modifications were there actually. The top panel, top right shows that the chairperson on the top with the other 10 faculties. Right now we are 11 in number. Left extreme is mine. The last one is from another faculty who is there. There are about almost 10 professors in the department and 1 associate and 1 assistant to a great extent to begin with. This is a legacy. Why? Because it started in 1882 with the George Cook as the one of the chairperson of the department, founder of the department at that time actually, then Metcalfe, like in British colony, then Venkateshachar, Venkatrao Telangan. This last 15 panel shows that the previous chairpersons, these are the recent past, almost from about 1994 onwards actually. We are about 27 chairpersons who have served the department very previously to this extent last year, Professor Usha Devi, then maybe Kokila. Right now she is heading the department as a chairperson. This is one blank box for you actually. If any one of you go through the master degree in physics and do the PhD program, certainly there are opportunities for you to join and to become the chairpersons of this department and to take the department in a right manner. You might have heard the talks from Sharad, you might have heard the talk from our colleagues, maybe previous recreative programs of that kind. The courses which are offered in physics department scans from the top from astrophysics, atomic and molecular physics, condensed matter physics, material science, nanomaterials, nuclear physics, soft condensed matter, and theoretical physics. No doubt, ISRO supported several courses like atmospheric science, space physics, plasma, planetary physics, along with atmospheric and space science research laboratory, which is doing in a very well way. And because of these collaborations, I joined in 2007. I told that ISRO started giving the funding and also have collaboration from 2009 onwards to start the course on atmospheric and space science. Supriya Nayak was the first student. She took the atmospheric science as one of the elective courses. Right now, we are involved in this activity in Chandrayan 1 as a learner, 2 and 3 as an user, Mars orbiter mission through projects, and Venus missions, for the possible Venus missions, particularly for the scientific objectives are considered. That's why I'm here for you. Nice compilation of this invitation. Thanks to the team actually. Being this, we created as an, once again, it goes to a link. atmospheric and space science research laboratory with all the courses put together. Some preamble is there. You can access later onwards actually. We are about 2009 to 13, that's the first batch, where you can find that the students who have taken up the atmospheric and space science as the specialization, starting from some 12 members. We can also find Supranaik is in first batch actually, where she is now heading this creativity and also. There are several. Maybe unable to upload with their photos. This is the second batch, then maybe a third batch onwards, then fourth batch until 13. Then if it goes for the 13 to 14, another some 14 students, 14 to 15, some other students, about 26, 15 to 16, almost 40 students took the atmospheric science as one of the course. 16 to 17, again 44 students took space science actually. Okay.
Is slide changing or we are at the first slide? Is everybody having same slide? Slide we are having title slide. Which slide you are?
Yes, sir.
Okay.
Title slides, sir.
Okay. Because of that, we started the atmospheric science. Fine. This you can see that preamble, the left top corner with the rainbow. You might have seen that white has to happen because of the dancing of the light, or maybe the reaction of the interaction of the light with the particles in the atmosphere creates a rainbow. Maybe some clouds. It's evidence of the great powerhouse of the Karnataka. But these three, maybe this is the pilgrimage place for you, Gurubindu, then another pilgrimage place for you, Gurubindu. These are the two what we can call tragedies, where the heavy downpour was occurred for Pinakini River and the things where Gurubindu and other neighboring places were drowned actually due to that, without predicting the rainfall or maybe a weather forecast on time or maybe on the real time. The center figure shows that it is the Narasimha Hall, Senate Hall of your case. To understand this, it requires the understanding of the atmospheric science, it requires the understanding of the physics, it requires the understanding of the dynamics in it actually. Right now we'll start how it has to go with that at least. The top panel shows that the life cycle of the sun, starting from the birth till to the death of the sun. Right now we are at the middle, roughly at the middle age, about 4.56 billion years. In the sense 10 to the power of 9 years of that kind. After that, it can go for the gradual warming. Then after 10 billion years of the one lifespan of any of the star may become red giant. Then the density increases enormously and it gets converted into the planetary nebulae. At the end, it becomes white dwarf. See the bottom panel, where left extreme is the sun and the right part of it are different planets which may not be aligned together always actually, but only for the pictorial representation they are shown on a one collinear path of that, and starting from Mercury till to the extent of the Neptune. Pluto is excluded from 2066 onwards by the space agencies. It does not follow certain properties of the criteria being a planet of the solar system. Earth is about 150 million kilometers away from the sun, no doubt. Yet the radiation, which is what we are receiving, starting sunrise till to the sunset, drives the atmosphere, drives the weather phenomena on the Earth, even the weather phenomena of the farthest planet Neptune together to a great extent. How that atmosphere was formed? Let's spend some 2 to 3 slides on that. Structure of the Earth's atmosphere, when it was formed several billion years ago, looked like almost like a star, almost 4.5 billion. The primitive atmosphere was probably comprised of the primary elements like the lightest elements, hydrogen, helium alone. These gases, due to the gravity, weakest gravity, might have escaped. Their contribution was very less right now to the atmosphere. Then electricity has happened. 2 lightning strokes occurred actually. These are the same sample pictorial representation of the lightnings. Due to the lightning, the water accumulation has started and the formation of the ocean came in the picture, even formation of the clouds and other things. If you scale the atmosphere to the thickness or maybe the diameter of the what we can call the Earth, the 6,400 kilometers is the diameter of the Earth. Hardly 100 kilometers is the thickness of the atmosphere. Left bottom corner shows that bluish color, shows that starting from this black is this bluish color is the thickness of the atmosphere. If you scale this to the size of an apple, the thickness of the apple size, particularly the skin of an apple, looks like the atmosphere. Or if you peel the what we can call either orange or lemon fruit of that kind, that should be the thickness of the atmosphere. Particularly fine. Being a composition, air or atmosphere is a mixture of gases, maybe of the permanent gases, means their contribution should not vary from time to time. Their contribution should not vary from space to space. Time is either in the morning or maybe evening hours, or maybe from winter to the summer, or maybe in terms of the spatial coordinates, like either over Himalaya or maybe over ocean or over land or maybe over America, their contribution should remain constant. That is why permanent risk, those contribution looks like remains constant for the time being, except the areas where it is involved with some industrial areas. Some of the pollutant contribution may dominate to a great extent. But gases with variable concentration will also vary. Those we'll call them as the trace gases. Solid and liquid particles can be named as the aerosols, which are suspended particles in the atmosphere. Their fraction is very small. But one can use the ideal gas law to describe the property of the air. There is no doubt. That is P is equal to rho times RT. That is, those terminologies are as usual what you are referring in the physics. Means to say that atmosphere should have the profile of the pressure, should have the profile of the density, should have the profile of the temperature to a great extent. You can see this shape. I will come back. This is called as an anvil. Anvil is occurs mainly because of the properties. Means Earth's atmosphere can be studied as the layers of the temperature, pressure, density, and composition. No doubt. That is, in terms of the composition, homosphere and the heterosphere to a greater extent, up to 80-85 kilometers, entire atmosphere is uniform with its constraints, what I told, that's why it is called the homosphere. Beyond that limit, you may find the layer of the nitrogen, layer of the oxygen, layer of the argon, layer of the gaseous materials based on their density. It is also classified in terms of the function like ozonosphere and ionosphere. Ozone concentration is very much enhanced or enriched at height of about 25 to 50 kilometers. And because of this layer, always life on Earth is protected. Earth itself is protective, mainly because of this ozone layer, where it blocks the ultraviolet radiation coming preferably from the sun and other galactic radiations. Ionosphere is a region where the ions are formed, abundant of the ions of the order of several thousands of the number. Communication is possible, and even rest of them cannot be possible at that time. In terms of the temperature, it is not showing a single structure, it is showing a wavy nature in such a way as you are moving away from the Earth towards the sun, temperature should increase, there is no doubt. But why it is happening in the homosphere? Because of the existence of the different constituents like nitrogen, oxygen, argon as the primary one, apart from the several trace gas elements, the temperature starts decreasing as you move away from the surface of the Earth, mainly because Earth acts like a source. Once it decreases and reaches the minimum of about 57 to 60 degrees Celsius at the tropopause, this layer is known as the mixing layer. Atmosphere is well mixed together. Then in the stratosphere, because of the ozone, temperature starts increasing and reaches 0 degrees Celsius at a height of about 50. From almost 50 kilometers to about 80 kilometers, temperature again starts decreasing, reaches a minimum of about minus 90 to minus 100 degrees Celsius at a distance of about 80-85 kilometers. This is the region is known as the mesopause, where the temperature is the lowest temperature. Beyond this limit, the temperature starts increasing. Up to this extent, all the phenomena of weather can happen. The troposphere is the region where all weather phenomena like El Nino, La Nino, clouds, rain-bearing clouds, volcanic eruptions are not eruptions. Even eruptions can go to that extent. Lightning activity, everything will be happening in the tropopause itself. Means to say that to understand this kind of a phenomena, we require the knowledge of the physics, and your role is very much essential as a physicist. Pressure also decreases as you move up, mainly because 90% of the atmospheric mass is within the troposphere over the equatorial region, maybe about 8 to 10 kilometers over the polar region. This region is known as the troposphere. As you move upward, the drop in gravity, the drop in the gravitation force which is acting on the particle makes the particles stay according to their density profile. As you move upward, the density drops exponentially. Beyond 80 kilometers, you may not find the atmosphere. But we may not find the atmosphere to a great extent. See that this is the line. Almost at the height of about 15 kilometers, you'll find 90% of the atmosphere will be over. At a height of about 50 kilometers, almost 99.9% of the atmosphere will be over. At height of about 80 kilometers, 99.999% of the atmosphere will be over. Because of this, why it is happening? Mainly because the relationship exists between Earth and the Sun. As we are also, human beings are also having a relations like an aunt, daughter, mother, uncle, brother, sister of that kind. Earth and Sun is also having some relation. What kind of a relation means? Earth rotates on its own axis, causing the day and night. There is no doubt. Earth also revolves around the Sun, causing the year, making the seasons, different seasons on the Earth. The left extreme on the top, you can see that the Earth is also tilted by certain angle, 23.5 degrees from the equatorial line, in such a way that the coming radiations will not fall perpendicular everywhere. It falls perpendicular only on some areas. Wherever it falls, the noon happens exactly at 12 o'clock. Length of the day and night should be of equal magnitude. For example, if we take like this, actually on March 1st, 21st, or maybe about September 21st, length of the day and night is becoming almost 12 hours on either side. As the more number of the radiations are hitting the atmosphere and warming up, more Earth will be more dynamic actually. If Earth is treated as non-rotating sphere, certainly what will happen? More radiation will fall on equatorial region. Air mass will rise by the absorption of the energy and move towards the polar region and sinks over there and makes circulation. This circulation is still known as the Hadley cycle. If Earth is treated as the rotating sphere, we can have either Hadley, polar cells, parallel cells because of the rotation. It rises, sinks over. It rises somewhere here, sinks over. At the polar region, comes. Because of this dynamics, we are retaining the temperature on the Earth. And at the same time, we should also have the either solstices like summer solstice and winter solstice. One of the seasons, the northern hemisphere is direct exposure to the sun, is known as the northern hemisphere, northern solstice. Otherwise, it should be winter solstice to a great extent. Like summer, winter, solar cycle you can expect because of the availability of the atmosphere and the dynamics which is involved. As a one representation you can see here. This is the one where the atmosphere is seen. This is one of the case. Very thin layer, hardly about 15 to 20 kilometers to a greater extent. 100 kilometers is the rarest case of that kind. With this understanding, we tried, because of, I told that we started atmospheric science and we thought of understanding the phenomena for the planetary science to a great extent to know that. We would like to move towards other celestial bodies, would like to move towards other planets to get it. Human being has started to fly after seeing the birds. You can see the left side diagram. A boy is waving his hands to fly. Of course, maybe a different issue also, but thing is that he could not be able to do that. But see on the right, the birds are flying. Birds are playing also to a great extent by waving their wings. If I move to that, and each person trying to negative, he could not be able to lift off his own way, even though. But the technology has evolved from last several 100 years in such a way that where there is a possibility of moving through an aviation from one place to another place, even to another celestial bodies like a moon, like a Mars, like other planets to a great extent. Our journey also started. Okay, here, see on that thing, the man has started moving on a vehicle to a great extent. Here also see that they are trying to fly by one or the other way. Moon is the one of the nearest celestial body where it creates so many beautiful things for us. To the dimensions, the left is on the Earth and the Moon to a greater extent. Clouds sometimes will come in between and obstruct the radiation which is coming from the Moon. It makes a spectacular phenomena. You might have seen during the eclipses, blue moon, red moon, such type of things, mainly because of the atmospheric composition that is varying on the Earth, and it creates a different colors with the colors for the interaction of the radiations, particularly coming from Moon towards the Earth, or maybe going from Earth to the Moon together to a great extent. Very abstract. This is the perigee and apogee. The sun is when it's nearer, moon is when it is nearer, looks like in higher dimension. If it is at the farther distance, looks like relatively at a smaller scale to a great extent. These are curiosity to fly and to try to reach the nearest celestial bodies have eventually made the scientific community to make the venture towards the celestial bodies, including the space agencies, that is Indian Space Agency, Indian ISRO, and also the other space agencies across the world. These are the different phases of the moon. You might have seen that from full moon to a new moon to a great extent, where it spans about 28 days to a great extent. And you can see that waxing of the crescent to the first quarter to the waxing gibbons, and this is how it can happen. I will not go in detail with respect to that, but the moon is also tilted by some off degree. That's why we are getting tilted by half degree. That's why we get the different shape of the moon what we are observing. And it is about 5 degree inclined with the equatorial plane. That's why we are getting the eclipses, like lunar eclipses. May not be very often, but it's still that possibility exists. It started with the Chandrayan 1 in the sense. Bangalore University started with Chandrayan only in understanding the phenomena, nothing to do with the research part of it. Okay. Okay, with this, we try to get the data, we try to gather the data, we try to gather the information. Where Chandrayaan-1, the mission has started with the different encircling the Earth with the different orbits, for about 6 to 7 up to 4 orbits of that kind, then entered into the moon mission, and from that moon, it has it encircled the moon and transmitted the data to a great extent. I don't know. With Chandrayaan payload, almost about 8 to 9 sensors, which covers rest of them, and the data is still available available for the scientific community and for the researchers through ISSTC and ISRO, where Srinath is one of the key role of scientists in handling this data. Okay, I first tried to analyze this data. We made an effort to see that they will, if you can enroll with the ISRO Science Data Archive, actually, okay, they will give the user ID and password with the thing. We should not go off misusing the data to a great extent, but if all data sets, all informations are available here. You can see that actually this is my login for 2008, for 4th December 2008 to till 20th December 2008. Some sample data we tried to analyze from our lab with the Chandrayaan-1 planetary data software we were. Here, this is the apogee and perigee sizes they have shown here. If you get that data, the data looks like that it's one type of a camera's pictures. We see that this is how that information is gathered, pixel by pixel for the regions. This is for the right extreme is for the northern pole, bottom one for the southern pole. This is the one for the polar region, particularly camera. TMC is a camera for the north pole of polar region with a digital elevation model overlapping. How we can able to see that the valleys, plains, hips, dips, and such type of the things we can. This is an overlap. This is the first effort what we put for the Chandrayaan-1. Based on that, and also the expertise with the Mars mission, we were working on Chandrayaan-2 to a great extent actually. Particularly in one of the payload, we can call it as the CHASE. CHASE is the neutral mass spectrometer, where it can make the measurement of the atmospheric constituents, particularly Chandrayaan atmospheric composition of the exosphere to a greater extent, which is developed by Space Physics Laboratory. It makes the measurement of the atmospheric constant, particularly in terms of the atomic mass units, starting from 1 AMU for hydrogen, that is 2 for the helium, 3 for lithium, like up to 300 AMU you can go. And with a mass resolution of 1 AMU, 100 kilometer polar orbit, Chandrayaan-2, it covers the polar region, particularly in the shadow region. The main objective of the mission is to make in situ measurements, that is the spot measurements of the composition and variability of the lunar neutral exosphere still going on actually. And with our expertise, our experiences with the earlier missions like Mars, actually, they tried to give the opportunity for us to continue the work from the work on the Chandrayaan-2 missions, particularly in the analysis of the atmosphere of the Chandrayaan. Of the moon through the Chandrayaan-2 missions to a great extent. These are some technical specifications, I believe. Role of Bangalore University as a team is nothing but the analysis of the Chandrayaan-2 level 1 data, that is the raw data, and analysis of the past data of the lunar atmospheric and the dust environment explorers and other supplementary data sets which can work with the Artemis and another space mission. Okay, and understanding or attempting some scientific questions which were not explored, and the phenomena will be addressed during this kind of analysis. The scientific objectives through this analysis leads to the composition in the lunar atmosphere over multiple lunar orbits, because the satellite always revolves around the celestial bodies. Sources and sinks of the dominant exospheric constituents may be inferred, and the global distribution of the species, particularly in the moon, should be known. The variation of these constituents on a daytime, on the particular neutral exosphere can be understood, can be known to the scientific community. At the same time, it's also possible for us to looking for the new science on the moon through variation during the passages through the geomagnetic tail. See that sun is here, earth is here. We are having a geomagnetic tail because of the magnetosphere of the earth actually. When the moon is here right now, moon revolves around the earth actually, takes about 1 month time and covers in 28 days of interval. How that the variations will happen, particularly the concentration of any of these constituents will vary, one can able to study. And at the same time, influence of the solar flares on the moon's atmosphere and how the influence of magnetic reconnections which will happen between the terminator of the sun to the earth actually will also be understood, because this magnetic reconnection region falls with the lunar region, lunar to the lunar pathway between the sun and the earth period. Variation near the solar perimeters can also be studied by making use of these observations, by making use of these concepts to a great extent. After a few years, we thought of having a planetary physics. Earlier, we started with the atmospheric science in 2009 to 10 actually. Then, and also the space science in 2014. From 2018 onwards, we were thought of having a planetary physics where during COVID period, we could not able to take the classes offline mode, the way we are having some online mode. This is one snapshot actually. I was introducing the planetary physics to the students, where the names of the students who have taken the specialization were named with the planets to a greater extent. Nothing to do that. Don't get confused with the names. These are the students. They were the students' names actually, which were just linked to see the atmosphere of planetary physics to a greater extent. And planets will not be streamlined like always like an circular thing, but it will be in a plane in a different position actually. The properties can be understood either in terms of their temperature, or in terms of the density, or in terms of the mass, or in terms of the brightness to a great extent. Being the temperature, the Venus with the highest temperature of about 460 degrees Celsius to a greater extent of about -280 is the almost the Neptune negative temperature. It can go to a maximum of about -170 for the Mercury when it is in a dark side actually, when it was in dark side to a great extent. At the bottom panel, you can see that starting from Mercury till to the extent of the Neptune, some of them they are rotating clockwise, some of them are rotating anti-clockwise. Venus gets almost reversed, means north side is down, south side is up. This is a peculiarity of the Venus. But on the second line, you can see that the time taken for complete one revolution, where the Mercury takes about 58 hours, Earth takes about 1 day, that's 23 hours, where Venus takes 243 days. In the sense, length of the day is more than the length of the year. Before it is completing one rotation on its own axis, it revolves around the sun to a great extent. These are some examples to study the planetary physics. If you want to go, if you want to start a journey, maybe for example to an Agra from here or Delhi, always you can go by roadways, no doubt, either by any car or maybe train, or you can also fly to a great extent by an aeroplane. But if you want to go to any of the island, certainly through ship or maybe aircraft. But if you want our journey to the moon, nearest celestial body, one of the natural, one and only the natural satellite of the Earth actually, and certainly we have to go through the rockets and satellites to a great extent. Or from Earth to the Mars, say again the same case. This is about 384,000 or 3.8 lakhs kilometer. It is hardly about 75 million kilometer, the distance of separation between Moon and Earth and the Mars. Why one has to study the Mars? Mainly because Mars is near the Earth, no doubt, and orbit is also an elliptical, both of them. Eccentricity wise, both eccentricity matches, and there may be a possibility of the potential for the human colony. Mainly the era like Corona, you might have experienced in such a way that people would not able to survive. If such type of diseases, if such type of an endangered things happens on the Earth, we should have an alternative way for our livelihood. For example, maybe very long back, maybe for 50 years back, if some kind of a what we can call issues comes, people used to leave the villages to a great extent. They may try to stay in the neighboring villages, but if the entire world, particularly on the Earth, all the colonial areas are got affected by virus, or the colonial areas are got affected by some kind of carcinogenic gases, things of that kind, then we should have another alternative way, parallel way for our livelihood. This is one way, one of the thought of that venturing the different planets. Okay, and the surface conditions are more or less similar to that of the Earth. Similar geology exists. Maybe the possibility of the availability of the water, atmosphere is thin, there is no doubt, and conditions are similar to Arctic and Antarctic of the Earth. Polar regions, how it is happening, the similar conditions are existing on the Mars. Mars looks like a little brother for the Earth, there's no doubt. See that in terms of the eccentricity, there is a commonality. In terms of the tilt, almost 23.5 degree, 23 degree. In terms of the precision, Earth is having a precision of about 25,000 years. 25,000 years. The Mars is about almost 175,000. It also having a precision because of the tilt. Some properties in terms of the radius, Earth is about 6,400 kilometers, half of this value. Density wise, again 50%. In terms of the gravity, again almost 1/3. And in terms of the year, The Earth, compared to the Earth, it is about 1.5 year. Eccentricity wise, the Earth's eccentricity is 0.17, but it is more than that. The now day wise, it is the same and increase the same place. But atmosphere of Mars is considered, it is made up of about 95% of carbon dioxide and 3% of nitrogen, and the water vapor hardly 0.03%, but no oxygen to a great extent. And try to go with the from one for the nearest planets. Actually, this is the one of the picture what I've seen, that we can't go straight like a cow flies one point to another point to a great extent. What happened when Earth at the Mars? See here, this is the Sun actually, and when this is the first position, this is the position of the Earth. When it was departed, it has encircled the Earth several times, mainly because of how to maintain the Hoffman principle, they can call. While boosting, we can go encircle with certain kinetic energy and retaining its centrifugal force. To shift it to the outer orbit from the inner orbit, it requires a booster. Through the booster, they will push it to the slightly push it to the outward. Once it is pushed to the outward, it maintains its trajectory. Always this is the perigee and this is the apogee. Apogee height goes on, increases from the planet, and finally about 5 or 6 orbits around the Earth, it travels in the space to the either Mars or maybe to the Venus or maybe to the Moon to a great extent. For the Mars is considered, it was the position of the departure. When it was departed, Mars is at this position. When it traveled, this is an earthbound orbit actually, how Earth has to move. Second one is the spacecraft. When it has traveled and coming to this extent, the Mars also came and there was a landing of, insertion of the satellite into the Mars orbiter insertion second call. Later few days, it entered into the Martian atmosphere. It encircled the Mars for about almost 8 years. It was planned for 6 months to a great extent, but because of the availability of the fuel and all the scientific advancements by the Indian Space Agency, Indian ISRO, and it will survive for the 8 years. Last 2 months back around February, they declared that it's not working. It's not working further actually. Why I am showing this? Because the left side, you can see that the photons which are coming from the sun travels a long distance beyond the Pluto, Neptune and Pluto, and it interacts with the matter which wherever it encounters, either maybe for the planets and planet's atmosphere, and also magnetic field also travels quite long actually. Here, this you can see that in such a way that they also take time and interact with the atmospheric constraints. When they interact with the atmospheric constraints, they change the dynamics, just change the chemistry, just change the radiation environment to a greater extent. To receive all those things, entire globe is having 4 international space stations for ground stations to support for the satellite launch and also for receiving the information. The left bottom corner is for the ISSDN, this track. Right bottom corner, you can see 32-meter diameter antenna where it receives information. If possible, you can see that. This is the first image of Mars color camera, which captured a very good information of the Mars. You see that chasma, boundaries, valleys, and height of this valley also you can see that actually this is Sivas chasma, this is Isis chasma, this is the Luna chasma, Luras. This is the picture how one they can analyze. But we are involved in a different kind, particularly Bangalore University Physics Department. This is the different. This is the how the satellite has orbited the Mars. This is from period to the periapsis of that time. Between 14 to 15 data we analyzed as an initial period, and this is for the entire period. How many encircles it has involved the Mars. Because of that, you can see that this is for the inbound contribution. This is for the outbound. In a sense, for degree when it is approaching towards the Mars, when it is moving away from the Mars, how that contribution has changed. More or less remains same within the error limit of that kind. This is the inbound and outbound. The contribution, there is a gaseous contribution also varies with the sun inclination, sun angle. That we have shown here in such a way. This is the space trajectory and this is the contribution. Red color shows the greater in number, blue color shows the least in number. With the increasing the zenith angle during the Martian year 32, that is the year wise, we can call that how that contribution is changing. When it is at the lowest point, it should be the higher. When it should be the higher point, it should be the lower contribution to a extent. See that the seasonality of the contribution of 32 to 34 and 33 and 34th year of the Martian year, how that gaseous constituents can vary. This one example shown for the carbon dioxide. Blue color shows relatively lower value of about 10 to the power 4 to 10 to the power 5, where the 10 to the power 5 it can pick up when it is at the lowest point, when it is at the lowest, when the spacecraft is nearest to the planet. The top right shows that the contribution of the different constants starting from hydrogen. I told that up to 300 atomic mass unit. We are shown here only up to the 100 atomic mass unit actually, how those contributions can be measured. This was the observation on 24th April 2015 from our own mom. We had a meeting for the reviewing of the total work or the entire work which was carried out the 8 years of India's space Mars mission actually 27. Here this diagram shows that the pictorial representation how that constants can vary. This is the observation from hydrogen to carbon dioxide with the time count. Water vapor may not be there, but the water which is when the spacecraft moves from the Earth, it may carry some amount of the water in the form of a vapor that will never be removed out. They can call it as that trapped water. That trapped water will have some kind of a measurement. But this water vapor content which is absorbed onto the spacecraft should be removed. Actually, this gassing they can call it as an outgassing. The pressure values of the order of 10 to the power of minus 11 of a torr to a great extent. Here, the same case on the 19th December, some constituents, from almost 8 to 10 constituents, you can see. This is another example of the measurement of the constituents. This is particularly in terms of the pressure, they can make the measurement. Depending on the pressure, we can estimate that the contribution of individual constituents or maybe the total constituents together. This is between 20th to 21st. This is again 21st. Yeah, see that this is the orbit. It is going at the lowest point and where the contribution is quite high. Here going for the same first 4 diagrams are that one. The next 4 are for the different dates, starting from hydrogen till to the extent of the carbon dioxide to a great extent. See that. See, this is the contribution of the gaseous, how it is they are varying. Blue color is for the path of the satellite. This is due to the solar zenith angle. As the sun rises and sun sets, actually, contribution can change from sunrise to the sunset to a value, but a total pressure can be estimated. This is the correlation of the Mars exosphere pressure with the daily mean sunspot number. As the sunspot number changes, certainly the contribution will also change. When the sun is very active during a minima, where there is no, when the sun is very reactive, cosmic radiation may not penetrate to the sheet actually. When the sun is at weakest position, usually the cosmic rays will enter into the atmosphere of either Mars or maybe on Earth actually. It is having a greater impact. This is another diagram showing that the same case for the 2 years of the observations. Wherever you are seeing the bluish color should be the lowest value. When it shows the red, should be of the head value. It's going with some kind of scientific observation such a way that we are on par with the NASA. ISRO is on par with the NASA for making the measurement, and internationally well-known agency for the space is considered. See that as the radiation which is coming from the sun takes some time to reach the Mars, to take some time to reach the Earth, it also takes some time to reach the Neptune. We can estimate that how long it will take, how they interact with the atmospheric constituents, how that contribution can change. The upper panel is for the same case. I don't know whether you can see the small dots. The yellow color is for the Earth, somewhere here. Yellow is for the Earth. Red is for the Mars. Okay. And the Mercury is shown is this color. Venus is in different color. I will show you here. I don't know, maybe you can able to see that. As it goes, it reaches, once it reaches, it hits. One can able to estimate that contribution. At a height of about 275 kilometer, at a height of about somewhere around 275 kilometer here, 270 and 275 kilometer here, we got a more contribution of the carbon dioxide, particularly due to the one of the major coronal mass ejection which was happened due to the solar flare. Here also you can see that enhancement. It is another way of representing these solar flares and coronal mass ejections, which were emitted during 2014. One of the event actually is well trapped and recorded by our observations and our findings through the MOM observations. This is the terminator they can call. During daytime and nighttime also the contribution can change to a great extent. That is the seasonality one have the observations. This is for the 2 years observations. As the height decreases, certainly the contribution will go up for all the cases. Another example is for the another event. See that? Yeah. We are having one chair, Saram Vishweshwaraya chair on collaboration. The motto of the chair is that to promote the atmospheric science, and space technology. It is on par with the ISRO's motto of harness, sustain, and augment space technology for national development while pursuing space science research and planetary exploration. We had a good number of the programs. Objective of the chair is to promote the science and promote the academics, and major activities which were achieved are, we had a one weather station. We are having a weather mini boundary layer mask. ISRO also supported one kind of an observations called Dr. Pusharati radio sound facility to make the upper air observations. Whenever satellites were launched, prior to the satellite launch, we had having a weather observations by sending the by launching the balloon with the by sending the data by sending the sensors along with that. Okay, we are having a collaborations with these agencies like the ISRO Space Science Office, PR Ahmedabad, the Radar Development Authority, ISTRAC, SPL, SHAR, NERL, and Chandigarh, involved in the missions what I told here. What I want to say is that with these interactions, earlier we started atmospheric science, atmospheric physics as one of the elective paper where Supriya Naik was one of our students, had undergone for only a semester. In 2014, the curricula was enhanced with the 3 papers for atmospheric and space physics, astro and space physics, and laboratory courses in both of them. In 2018, we went with the higher paper. It's on par with the ISRO's and also having a collaborations and interactions with the ISRO scientific community in designing the curricula in on par with the standards. 4 papers. Right now, we are referring almost 8 papers. Astro and atmospheric physics is one of the software which will be studied by all the students in the first semester. Okay, this is in for the 3rd semester, atmospheric and space physics, and space and weather climate as another paper. Planetary physics as the 4th semester, and practicals for laboratory classes for the both, including computational lab and planetary physics. Also the practical work. This is how the course has evolved. The collaboration is very much required. My humble request is in such a way that ISRO has started with bullock cart, fine, okay, but it went into the extent of launching 108 satellites at one go. ISRO's economy is considered. ISRO, Pakistan also started the space agency. India also started the space agency together to a great extent. So far, Pakistan has launched 2 satellites. ISRO so many, more than 70 satellites, but don't compare with the country. Okay, ISRO has developed Desi versions of the Google Earth, like Google Moon, One and other things. When with Chandrayan, India is the 4th country in place to flag its flag on the moon. ISRO to journey to the Mangalyaan, making our Mars, making the India the first country to do successful in its attempt. That is why here you can see that in 70s when Aryabhatta was there, that on the 2 rupee coin, you might not have seen the 2 rupee coin. I don't know. It is unfortunate. Just kindly see that this Mars, Aryabhatta was engraved as the symbol on the 2 rupee. Now the cost also gone up to the 2,000 rupees. During the Mars mission, they put that Mars pictorial representation with that. Of course, as far as the budget is considered, 1 year's NASA's budget may be almost equivalent to 40 to 45 years of ISRO's budget. ISRO also makes money out of launching the satellites and giving the information to the public domain. Some of the photographs where we conducted some events outside Bangalore University Physics Department, some quizzes, some conferences. This is another place. This is another place. Our faculty members around 2018. This is one of the program conducted at the National Degree College of not in Gauribidnur, Basanugudi.
Jainagar.
ISRO supports this facility. Another one, yeah, just I'm scapping. This is one of the greatest facility where balloon is up about a 2-meter diameter, can go up to 35 kilometer altitude. This is one more observation where we are having in real times observation of lightning activity. Our students reading during balloon launch. Meeting at ISRO for the Mars mission. This is for Chandrayan 2, finding Srinath and others. Chandrayan 3 recently held at the ISSDN. Thanks to the ISRO and others for giving us an opportunity. Bangalore University is having a collaboration with several universities, several institutions, and almost so what 13 crores of money with the different agencies, government and non-government. This is the collaboration of the Bangalore University Physics Department with various agencies. ISRO is on the top to a great extent. Our alumni, Kiran Kumar sir, is an alumni of our department, with Narasimha sir, others. Through University Global Ranking, almost 1,000 PhDs were awarded in last 5 years. About 193 award recognitions we received. We are #1 public affiliated university in India, 7th in India, and 242nd in world rank. According to some ranking by the national agencies, the Bangalore University is in 64th and 37th in Greece. This is the last slide. Being a student, always you have to engage and try to explain the phenomena, whatever you studied, evaluate yourself, extend the knowledge, and try to explore. In general, we will learn 10% what we read. It's common for up to 10th standard. 20% what we hear, still. 30% what we see, maybe +2. 50% what we see and hear. 60% what we write from the graduation onwards. 70% what we discuss after graduation. 80% of what we experience. 90% we will learn what we teach. I am at the last stage. I am learning all those things from the last part. Thank you for your patience. If you are having queries, you can ask or you can drop. This is the entrance of the Bangalore University. All are requested you to welcome, to visit, and to also to join the course after completion of your graduation. Thank you.
Thank you, sir. Now it's time to ask your questions or inquiries. I'm just allowing everyone to unmute yourself and you can ask questions to sir. Any questions? You can raise your hand and you can ask questions. So just I want to ask, what are the activities regarding atmosphere physics is going on, sir, now at present? Any projects are there for MSc students? Sir, you are muted. Still muted. Okay.
Just give credentials for unmute. Okay.
Yes, sir. Yes, sir.
Okay.
Yeah. Audible,
Okay.
sir.
Projects in the sense we are having in weather data, we are having in observations, we are also having an atmospheric phenomena. Particularly, the work is going on total electron content or analysis of weather phenomena, analysis of some profiles of all meteorological parameters, and some development of smaller level, per scale level, some development of some sensors like temperature sensor, pressure sensor, wind speed, wind direction sensor. Last year, one team instance, one batch of the students have done that experiments and correlated with that one. Otherwise, we are using the satellite data, satellite observations, and also ground-based observations for project work.
Sir, just give me some spotlight on how it will help in future studies, sir. For MSc students, so many students are there. So for them, just give me some ideas, sir.
See, they will study a lot of things on theory, but if they do experimental work, if they do involve in analysis part, if they are involved in assessment, actually, certainly their theories will be validated through their analysis. Maybe either project work or maybe in laboratory coursework also, doesn't matter actually. And it improves their knowledge. It improves their knowledge and understanding the phenomena.
Thank you, sir. Any questions? Sita ma'am. Okay.
I just wanted to ask him one question.
Madam, namaste, madam.
Namaskara. I just wanted to ask you one question. You named some students who had worked on various atmospheres of planets. So, did only those students work or many students work? These students made some significant contributions or something. You said their theory will be valid, etc. So, can you take, for example, just Mars or any one planet and say what they did? Any planet which you like.
Okay. No, madam, because they were the students of the planetary physics. While introducing them, actually, without their knowledge, I named them. Then they continued with some assignment of understanding those planets, particularly through their work, madam. Since each student was given with one assignment of working more on that planets to a great extent. While
okay.
that's the only representation, and they exchanged the information among themselves.
Okay.
Particularly, one of the students was very alert in taking the name of a Saturn.
Okay.
I don't know, but I try to convince.
Okay. Thank you, sir.
Thank you, madam. Thank you, madam.
Ganesh Raj, sir. No, maybe disconnected, I think. Anybody wants to comment or anything you can do?
I would like to add, Sita madam was there in program, space science program office for supporting this course. Almost 5 directors were there, starting from Jayati Datta, Jayaraman sir, Sita madam, and recently TP Das. Still the course is going on.
Yes, sir. I think no questions.
If there are no queries, I'm thankful to the creative team and particularly Suprinayak and Srinath. We'll be in touch for further also. If you want to send students, finally we are happy to exchange our laboratory and also extend the facilities to us. Thank you.
Thank you, sir.
Yeah, I think Supriya was asking whether they can send students for some summer internship, that kind of thing.
Yes, sir. Yes.
They can send, madam. They can send, no issue.
Yes, sir. Mini projects or anything
Yes,
for
yes,
UG,
certainly they can take it on.
we can promote
Yeah,
them.
summer holidays,
Sure.
summer holidays, etc. Whether they can come visit and do some project.
Sure, madam. Sure, madam.
Yes, sir. That will be very useful for UG students, sir.
That is true.
Okay. I could like to express my heartfelt gratitude to our eminent speaker, Dr. Kamsali Nagraj, sir. Thank you for your insight, knowledge, and experience has been invaluable, and we are truly grateful for your contribution to this talk, sir. And I thank each and every one of you, our virtual audience. Your presence and active participation have made this talk a truly engaging. Thank you for joining us. We are winding here. Thank you, sir.
Thank you.
Thank you.
Thank you, madam. Thank you. Sir, namaste. Thank you, sir.
Namaste. Thank you.